Welcome to my channel. Today I'll be talking about how to use schematic diagram to trace 19-volt power array on the motherboard. The sequence, how the voltage move from the adapter down to the current sensor and down to the charging circuit. Just a simple illustrator. Before we start, don't forget to like and subscribe to my channel. And once again, I'm working very hard to work on the audio output of my videos. Thank you. Today we'll be working with Dell. Let me see if I can see the description here, but better off. This is Dell Latitude E5420 Evertech KRUG 14. That's what we'll be working on today. And on the schematic diagram, when you go down a bit, let's zoom it out so you can get a very good view. Yes, you can see the modem number down here. Then if we are going down, let's see what we see. We see the block, the table of content. The table of content, cover page, the block diagram. We've already talked about the block diagram. I guess we'll talk about the block diagram. I just want to give a little illustration of how the 19-volt power array work on the motherboard. Then subsequently we'll move further to explain the technique and how it works on the motherboard. Okay, for now we are looking for AC DC section on this motherboard. This is the vehicle for the graphic. This is the battery section. This is page 10. He said this is in page 10. This is page 10. Let's see. Let's just go down to page 10. Okay, we are here. As you can see, the design of this motherboard here is nothing different from what you'll be seeing from other motherboard. You see from this place coming. This is the DC in here. As you can see, this is the DC in, this is the adapter in, this is the adapter, this is the adapter, what's it called? That is the adapter connector. Let's go for 2. That is the adapter connector. This is the DC in, and here you will get a 19 volts will be coming in at this point in place. When 19 volts come in here, you have 19 volts. You have 19 volts. When 19 volts come in here, when 19 volts come in here, it will move to the drain of this MOSFET. Come to the drain of this MOSFET. These are 4 pins that are connected together. The 19 volt will come in into this pin also, into this pin. The 19 volt will be there. From this point in time, the 19 volts come in here and go in. Also, there is a diode connected here. There is a diode that's connected here. You can see it here. You can see the diode here. Also, let me get it clear. The 19 volt also flow to this place. Down to this diode. You see, then from the diode it passed out from the, you can see it now move out from the diode also to the source of this MOSFET. Are you seeing it? So here now we have 19 volt also. Here 19 volt. Volt. Now the 19 volt is already out of this place. Now 19 volt move down to the current sensor. Down to the current sensor. Now before the current sensor, the gate of this MOSFET here now move down to these two resistors. This is 10k resistor and this is 10k resistor. Then from this resistor we now move to this transistor. This also here, this is also a transistor, this is a transistor. You can see the label here. And this is a P channel. This is an N channel transistor, because the diode inside here is connected to the drain. Or should I give you a more zoom so you can see what I'm trying to say here? You can see the diode inside here is connected to the drain of the transistor. This is AC available, AC AV underscore in underscore AV. Now these two resistors here, these two resistors will give us the voltage here. If you are using your current, what is it called, your current divider, then you get the voltage that is coming in here. That one will be treated in a different class so that you understand the voltage. You will not be expected to get 19 volts here. Now to be this AC in should be around maybe 2.6 volts or 2 something volts, but it's not up to 19 volts. Then the gate voltage also is still coming down. It's still coming down. The gate voltage now 19 volts is on this current sensor, the both axes of the current sensor, to give us, if we trace the both leg, they will give us a CSSP and CSSN. Those two current are coming from the current sensor. Remember, those MOSFET and transistor here, what they are doing here is to protect the power that is coming from the battery and the power that is coming from an adapter, so that they should not like interwove each other. When the battery is connected and the adapter is not connected, it will switch the power source to the battery source. And when the power source is connected and battery is not connected, it will switch the power source to the adapter source of power directly. That is what they are using. That is why you see they will use them interwoven. Sometimes they use N channel and P channel, mostly N channel and P channel, or N channel, P channel interversely so that they will not like cross each other. The voltage will not overlap each other. Now, the gate also of this MOSFET will come down to this charging circuit. This charging circuit. This side is coming from the battery. This side is coming from the adapter to give us this 2 voltage SSP, and let me zoom it up. Trace it, you can see pin 28 and it's pin 27 and 28. You see them? You see them? You can see them. These are the 2 of them. Then the AC in, if you come here, look at it. This is the current that is coming from the gate of that MOSFET. That is the AC in. Then the DC in, you can see this is the DC in. If you trace this one also, you see the source of this current. You can see it also is going up. Then we have the you can see the CVV. This charging circuit, all this charging circuit is a class on its own. We're going to treat it so that you see how it works and what are the voltage requirements, because the 2 IC from the charging port, you can see the 2 of them here. The both IC here are N channel IC. The both IC here are N channel. Now, what I'm trying to say here is that from the drain here, the battery voltage is coming from the drain, but this conversion here give us what we are trying to track: the phase voltage, the voltage that's going to charge the battery. That is what this chip is doing. This chip sense and control those MOSFETs to charge this IC. That is what this power circuit is all about. You can see the AC, okay, you can see the ground, you can see the VDD, the SIL, the SCL, the SAD, the DAC, the CCV, the CCI, the CCS, the reference voltage, the feedback voltage. You can see all the LDOs, the DLDOs. Now, the VCC, this is the main source of the power for this chip. But as you know, the main power of the chip is 19 volts. This chip will get 19 volts to enable its power to turn this chip on. But there's other requirement that will enable this chip to function very well. In my next class, I will talk more particularly on this chip. What are the basic requirements for this chip to run successfully? You can see this same chip again is driving the upper gate and the lower gate of these 2 MOSFETs. If you trace the gate, this is the gate 1. This is the gate. DHI, that is higher gate. LX supposed to be lower gate. Something, yes. Okay, let's see the lower gate. See the lower MOSFET gate here. You see, this is it, DLO. This is the lower gate of this MOSFET. Then this pin here, this middle pin, is the LX. Most company designing as phase. That is the phase voltage, because it senses the current that come through this both MOSFET, because this one is connected to the ground. The voltage coming here from the drain here, it came out to the source. From this source, it come to 4 pin. From this 4 pin, it come out in this 3 pin here. Then it connected to the ground. Then this LX voltage, which is the sense voltage, we sense it to this inductor. Then this resistor, and all these filter capacitors that will filter the current. Then it give you the output of the charging. The system will start charging. That is the concept of this chip here. But in our next class, we'll be talking about what are the voltage we'll be meeting in different section, like ACOK. What is the voltage required in ACOK? What is the voltage required in the VDD? What is the voltage required in the what is the voltage required in the what is the voltage required here? Here. Here. That is the SCL. Here, SCA. These are the common important chip. VDD, ACOK, the ACOK is the bad cell. The bad cell in some is skip cell, some is SS. So it depends. You have to study different kind of manufacturer. What is it called? Manufacturer language. These are the feedback. What is it called? Key is one. Is only one. Here's the feedback. They are connected together. 14, 15, and 16. Here's the feedback. Here's the feedback line. Here's the feedback line. Then the SSN and SSIP. Those two voltage, okay, they are also required. The VCC is the first one that will bring out the power of the voltage, and this other two, the SSN and SSP, they are coming from the current sensor from the above, as I explained. Then the AC in, I've talked about it. Then the reference voltage. Then I will talk about these two MOSFETs. Talk about these two MOSFETs. This and these two MOSFETs. Then everything that comprises of this chip we will discuss in our next class. Please drop your comments. Feel free to drop your comment, and if you have anything you want to understand that I'm not treating, or if there is anything I skipped, you can be able to ask me to put more light on it. So thank you for watching.